Welcome to the Real Python Podcast. This is episode 193. How do you avoid the bottlenecks of data processing systems? Is it possible to build tools that decouple storage and computation? This week on the show, creator of the pandas library, Wes McKinney, is here to discuss Apache Arrow, composable data systems, and community collaboration. Wes briefly describes the humble beginnings of the Pandas project in 2008 and moving the project to open source in 2011. Since then, he's been thinking about improvements across the data processing ecosystem. Wes collaborated with members of the broader data science community to build the in-memory analytics infrastructure of Apache Arrow. Arrow avoids the bottlenecks of repeated data serialization and format conversion. He shares examples of Arrow's use across the spectrum in tools like Polars and DuckDB. Wes advocates moving from vertically integrated tools toward composable data systems. We discuss his work on Ibis, a portable dataframe API for data manipulation and exploration in Python. Ibis supports multiple backends by decoupling the API from the execution engine. This episode is brought to you by Posit Connect. Posit is dedicated to open source data science tools, and Connect helps teams manage all their data science publishing. Learn more at pos.it/realpython. All right, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hey, Wes, welcome to the show.
Thanks for having me.
Yeah, I'm very excited to talk to you. There's just a variety of things I'd like to talk about. One of the major ones is going back to this theme that I see in a lot of the talks that you do about how when you created Pandas back in 2008, that you kind of were dealing with the state of the industry at the time, the state of the hardware that people had at the time, and what data maybe looked like at the time. And maybe we could talk about, what were some of the limitations you were facing back then when you originally started the project and why it's led to you having to really think about what we're doing today and where things need to go.
Sure. Yeah. Happy to talk all about that. I mean, it's been almost 16 years now. And so obviously a lot has changed, not only in the world of computer programming, data science. There was we called it statistics and statistical computing and just data analysis back then. But I think at that time, I was really concerned with just making Python a language where you could succeed at doing really basic data work. And so a lot of the themes of the recent decade have been around how do we make it interoperable, scalable, performant. And if you go back 16 years ago, well, those things like performance and scalability and interoperability and all those things, those were like kind of pipe dreams.
Yeah.
At that point in time, just things that we might have dreamt about, but getting to the point where we could read CSV files and do basic stuff that you might do in Excel or that you could do in R in Python and with a reasonable API.
Yeah.
Like that was already a lot of work. And so it's taken a long time to get to the point where we can start thinking about some of these higher order concerns. But yeah, no, it's been a very interesting process to not only build the software, but then build the open source communities around the software and basically scale the community around these projects. And so it's been an incremental thing, but already, the passion of my career. So I've really enjoyed the work, and it's given me a lot of satisfaction to have the opportunity to be involved in these projects and to do things that have impact in the open source world.
Yeah. So you led the project till 2013 and then turned it over to the open source community. What was some of your thinking behind that? Or maybe what factored into your decision there?
Yeah, I've definitely spoken about my history with the Pandas project and how I was working for a quant hedge fund, and I convinced them AQR to let me open source it at the end of 2009. And then I started giving talks in the Python community, and I dropped out of grad school to work on Pandas in 2011. I wrote my book Python for Data Analysis, and then in late 2012, I teamed up with my colleague from AQR, Chung, to found Datapad. And we raised a little bit of venture capital and moved to San Francisco to build a startup. And we intended to use Pandas and the early Python data stack to build a visual analytics tool with Python programmability. Yeah, it was very fun project. But I realized that I wasn't going to have time to be a full-time open source maintainer on Pandas. And at that time, Jeff Reback and Philip Cloud had really stepped up and started doing a lot of development work in the project. And these were people that I'd met in person and felt like represented the values of the project, were people that I trusted to manage the community, and they were really eager to do that work. So I felt really comfortable handing over the reins of the project to them. So it was pretty natural, like a pretty natural transition. And at some point, like, we did create a governance document for Pandas, and established me as the quote unquote benevolent dictator for life, similar to how Guido van Rossum was the benevolent dictator for life for Python up until recently.
Yeah.
But in practice, I've rarely had to exercise the role of the BDFL, like breaking up impasses or disagreements in the project. And so I think as far as open source communities go, it's been a really healthy community, and has grown, to thousands of developers over the last 10 or 11 years, since I haven't really been actively involved over that period of time.
Yeah, definitely. I think about it, and it's just the tool that is always mentioned in data science as far as the Python side. And it has such momentum, you might call it, like as far as the amount of projects that are using it, and then sort of a history also. And sometimes I think about that, like, as the team that's heading it currently looks at adding features, it's like this massive bus that's traveling down a one lane road. And if it's going to make any turns, it's going to maybe take some effort to try to, like, okay, let alone like turning something around and moving it. So I wonder about that, like adding features and modifying things. Has that been your experience as far as trying to make changes?
Yeah, from what I've observed from the outside, it's been hard to change things in Pandas. Firstly, because I think one of the reasons that Pandas is both loved and reviled is that it takes responsibility for so many different things in one really large code base.
Yeah.
And so that has led to these massive monolithic releases where everything, including plotting and value formatting, like formatting tables in the console, and like all the stuff that Pandas does, are part of this gigantic monolithic code base. But there's also like the internal API surface area of all the things you can do with Pandas data frames. I mean, if I could self-deprecate or criticize my decisions 15, 12 or 14 years ago, I think that in some ways Pandas data frames do too much, or like there's some things that they do, like multi-indexes and multi-level row indexes are one example of something where you can do all these cool pivot table things, and you can reshape these massive multi-dimensional data sets with data frames.
Yeah.
And a part of me feels like, if you look at what Polars is doing, they said, no, we're not going to do row indexes at all. Like, row indexes make things too complicated. We want Polars to be simpler and focus on performance and scalability, and not do all that row indexing craziness that Pandas does. And honestly, I feel like that might be the right, in retrospect, like that's probably the right, it would have been the right approach to put all that pivot table reshaping stuff into a separate data structure that's concerned with like making pivot tables and data presentation and things like that. It just wasn't obvious at the time. And so it's only with hindsight that you can really say that. I think another thing I would have liked to have been able to do that I think wasn't feasible early in the project is that pandas should probably be broken up into, I don't know, 6 or 8 or 10 sub packages that are each released
Yeah.
independently. So you could have some of the components of the project that can move with a higher velocity. So for example, if you make a change to how values are formatted in the console or in the IPython or Jupyter notebook, that part of the project could be released a lot more frequently, whereas code that affects the internals of the library and how data is managed and some of the algorithms and core computations in the library, like that would be a little bit more slow moving and would have maybe quarterly releases or release twice a year, something like that. But, it's worked for the project. It's over 15 years old and, it's still growing like crazy and it's being used by tons of people. It isn't trying to be the fastest or the most scalable library out there, but it's become a Swiss Army knife. You don't use a Swiss Army knife to cut down trees. So, but you can use a Swiss Army knife to do a lot of different things, and Pandas is a lot like that.
Yeah.
And so I think the fact that it's become this kind of multi-tool that everybody can learn how to use and they can solve all kinds of different data problems with it. It can be like a great unifier across data teams. Like everybody knows how to use Pandas, and if you've got larger data sets or you need to do something more scalable, you can use Polars or you can use DuckDB or you can use your SQL data warehouse. And that was kind of one of the motivations for creating Ibis, was to bridge the world of data warehouses and SQL-based systems and pandas. And it's only in the more recent years that project has started to take off, as data warehouses and SQL-based systems have seen a renewed surge of adoption and kind of taking over the enterprise.
I got like 3 or 4 points there. I was literally going to ask you about how would you have changed things if you were able to start the project now? And you've addressed many of those thoughts already with what you just said. I also want to address the idea of this multi-tool, and that's how Python is thought of in so many ways as a programming language, is that, the kind of goofy joke that people sometimes say is that Python's the second best programming language at everything. Like it may not be specialized into one or two different areas, but you can kind of use it for whatever you need to be able to do. And I definitely feel like Pandas kind of is in the same ballpark, and Excel kind of in the same way. It's like this sort of tool where you can just go to it and people know it and get going with it. But then I got really excited about you mentioning Ibis like right away. Like I'm like, okay, cool. You seem to have a passion for this idea of decoupling tools in some ways, and maybe that comes from the background of what you just said. And sort of, I don't know. You mentioned, I think, in this other talk about removing lock-in. Do you want to talk a little bit about the idea of decoupling these tools and how that relates into the? Is it Ibis or Ibis?
We say Ibis.
Okay,
Yeah.
Ibis. Okay, cool.
Yeah. There's also like the Hope Hotel brand. Like, I don't know whether it's Ibis styles or Ibis styles. You see those Ibis hotels around the world.
Okay,
international hotel brand.
Yeah.
But yeah. Well, there's a lot to unpack there. So to go back to the late 2000s or early 2010s, I think the whole Hadoop ecosystem, the first wave of open source big data systems, was driven by this idea of decoupling storage and computation. So the idea was that you would put all your data in a large distributed file system that's hosted on commodity hardware, and then you would build these computing engines that would execute jobs on the data in that distributed file system. So we had the Hadoop file system, and then we had the original Hadoop MapReduce and Hive, which executed SQL using Hadoop MapReduce, and a whole ecosystem of projects which were largely written in Java that ran on top of the Hadoop file system. And these were all inspired by similar work that Google had done with their GFS distributed file system and Google MapReduce and the original MapReduce paper. And so you already had like this idea of moving from the old school world of the 90s and the 2000s of the vertically integrated data warehouse. And so you'd have the storage layer, the transactional layer, the query engine, the query optimizer, query planner, query front end would be a vertically integrated system with SQL on one end and storage systems at the other. And so the idea of like starting to break these systems apart so that you can say, okay, like, well, let's let the storage be its own system, and let's have multiple different computing engines. And, you could use SQL to talk to these systems, or you could write Java code or Python code or Ruby code to write jobs. I was at Cloudera for a couple of years. So they bought my company, Datapad, in 2014. And so I got to work closely with many of the key people in the Hadoop ecosystem. And so I was exposed to these ideas of, modularity and composability and disaggregating storage and computing. And I'd also been deeply affected by the fact that we had to build all of these systems and libraries ourselves for use in pandas. So we were completely on our own. We had to build a whole bad database, like a query engine, like the internals of pandas that does all of its computations.
Right.
We had to build all of our own data interfaces to read data into Python, to read CSV files and read data out of SQL databases and do all of this stuff. And so I was really attracted to the idea of being able to reuse software and code and systems between different projects. And what I really wanted was, like, if you go back to my talks in like the 2015 era, I was talking about, wouldn't it be awesome to have a really high performance C or C++ data frame library that we could use in every programming language that could execute these analytics workloads that we had built ourselves in pandas, but could be done portably, used in all of the programming languages. And, it just didn't occur to me that that a few years later, I would be talking about what we now call, DuckDB or Data Fusion, or, now there's a number of projects, Velox from Meta. So now, like, we have these reusable execution engines, and that's what I really wanted back in 2015. I was like, I don't want to have to keep building this stuff myself. Like, I want to work with other developers.
Yeah.
I want to create these reusable software components so that we can focus on building one reusable piece of really high quality data processing software that can keep getting faster and faster, can take advantage of hardware acceleration, use GPUs, all that fun stuff. Like, I'd used GPUs in my PhD. So I started a PhD in statistics, and in 2011, we were using NVIDIA GPUs to accelerate Bayesian inference. So basically Markov chain Monte Carlo workloads using GPUs. And so I'd already seen the potential of using GPUs for accelerating statistical computing workloads. And so it just made sense to me that like, clearly the future should look like, we have fewer components, we have a lot more data, but the data is being processed by a lot less code. So there's fewer components, less code to maintain, more collaboration, like more investment in these shared systems.
Seems like there's a lot of repeatability that was there. Like, what I mean by that is that everybody was creating, or a lot of people at the early days in this field were creating tools that were not unlike pandas, that did kind of everything, because they felt like they had to be the one-stop shop that had all the solutions. And it's like kind of a bit of a wake up to this idea that we can specialize. We can have GPUs doing this part of it and this doing that part of it. And so I kind of like that idea, that, again, the decoupling.
Yeah, I mean, I think it's natural for people to build vertically integrated systems, because ultimately collaboration is hard.
Yeah.
Organizing people to collaborate and cooperate on building shared solutions takes a lot of work and a lot of time. And so if you're under a time constraint and you need to deliver a working solution, and this is especially true if you're a business. So imagine you're building a database or some other data processing company. You can't afford to spend an extra 6 months or an extra 18 months investing in some external joint venture or open source collaboration in order to ship your product. You say, okay, well, we're in the interest of expediency and getting a product to market, solving a customer's problem. Like, we have to build these things ourselves and get them in a customer's users' hands as quickly as possible.
Yeah.
But what happened is that by the mid 2010s, that we'd already been through multiple eras of that way of working. And so what we found was that many different open source projects were running into the same classes of interoperability, modularity, composability problems. And so in order to basically level up and achieve the next plateau of performance and scalability, like, we were forced to stop and collaborate with each other to build open standards that would facilitate that collaboration. And so the Apache Arrow project was one concrete thing that came out of that need to establish open source standards for computing engines. So in order to build modular reusable computing engines, we needed to have an interoperable data format that was language agnostic and could represent large tabular data sets for these, SQL workloads or data frame operations. Yeah, so in some sense, I think people asked at the time, they were like, well, why didn't we do this in the 1990s or the 1980s? Like, why are we doing this in 2015? And it was that the ecosystem, the commercial ecosystem and the open source ecosystem was able to move quickly and make progress and deliver solutions that were essential without needing to solve like those problems, or at least, like, again, in the hierarchy of needs, kind of what I was talking about earlier, early days of Python and data analysis in Python. Like, the concerns that we were dealing with at that time were so mundane that these like more higher order concerns of like, okay, well, how do we have a super fast interoperability format for plugging Python into all of these other data systems and computing engines? Like, that was just so far down the road that we couldn't even, begin to think about it, because it would be like solving a problem that doesn't even exist yet.
Yeah.
So it just, what I've seen is that often these problems, people arrive at these problems independently. And so it was fortunate that I was in a position where I had a lot of social connections, work connections with many open source developers who all knew each other. And so we were able to bootstrap some of these open source collaborations very efficiently. Like, all the right people who worked for major tech companies were able to get together, have high bandwidth conversations about what problems we were seeing in our respective systems and whether we thought that there was a basis for collaborating and building something together. And there was enough history, track record of working together, goodwill, history of good collaboration, communication, that we were able to solve like the hard social problem of getting new open source collaborations going. Because often that's the hardest part of building these software projects, the social side. I mean, the technical problems by comparison are much easier, but getting people to get on the same page and be on the same wavelength and collaborate with each other it's really hard. Like, bootstrapping that initial collaboration with somebody you've never worked with before it's taking a great leap of faith that you're going to be able to sustain a collaboration for a period of many years. Like, I'm going on working with Jacques Nadeau on Arrow and other open source initiatives. And I didn't know Jacques very well when we started working on Arrow together, but I had a good feeling, and he had worked with other people in the community. So there was a good degree of social validation that Jacques was somebody that I could trust. And I got a good feeling in initially working together. And 9 years later, that was a good bet. And we've been able to build a lot of, really really important stuff together.
Posit, makers of Shiny and Quarto, and formerly called RStudio, is the public benefit corporation dedicated to making great open source tools for data science. Let me ask you a question. Are you building awesome things? Of course you are. You're a developer or data scientist. That's what we do. And you need to check out Posit Connect. Whether you're building with Streamlit, Shiny, FastAPI, Dash, or Quarto, make deployment the easiest step in your analytics workflows. And ease your IT team's workloads with Posit Connect. You can try Posit Connect for free for 3 months by going to pos.it/realpython. Taking that back a little bit, I'm fascinated with Apache Arrow. I think that project is really interesting. And I feel like a lot of people are maybe a little confused with what it is and how it kind of fits into this world of databases and this way of kind of working with stuff. And I've tried to describe it myself, this idea that it's, an in-memory format for your data. In a lot of ways, it's trying to get past some of the bottlenecks of having to push something into a database and pull it back out and all that kind of conversion overhead that ends up just really spinning cycles and so forth. And in some ways, if we could just keep this representation of data in memory, it could just save so much effort. And I don't know if I'm explaining that well or not.
Yeah. I mean, I mean, Arrow solves a number of problems, but yeah, one of the big ones is avoiding data serialization and data conversion. And so nowadays, you can build a full stack web application with advanced low latency analytics, querying, filtering, aggregation using DuckDB compiled to WebAssembly in the browser, combined with processing on the backend, which could be anything that speaks Arrow. It could be something written in R and Python and C++. It could be a database engine that has Arrow compatibility. And so now you can take an Arrow data set from the backend of your full stack web application, send it to the browser in Arrow format. So no need to convert to some intermediate representation to send over a WebSocket, and then immediately hand that blob of data off to DuckDB and WebAssembly to process, because DuckDB speaks Arrow natively. And so if you went back in time, without Arrow, you would need to invent some intermediate data format, at each of those stages. Say, well, okay, how am I going to send data to the JavaScript layer of the web application? How would I expose the data from the JavaScript side to DuckDB compiled to WebAssembly? And so if DuckDB, your web application, and your backend services all used different data formats or had no standard for talking to each other, if you needed to move a large data set, that would start to become meaningful latency in your application. Like you could just spend hundreds of milliseconds or full seconds just doing conversions between these different components in your system.
Yeah.
And so when you use Arrow, all that conversion and latency killing interoperability overhead completely goes away. And we also, we designed Arrow to be efficient just used by itself within the context of a single system. So we knew we needed to have something where we could move massive amounts of data from component to component in a system, but also there would be benefits to adopting Arrow within a system, in that it's designed for fast processing. You can use it efficiently on modern CPUs, on GPUs. We used our knowledge of how we learned from the database literature, a lot of the research that have been published in high performance computing about the benefits of the columnar memory layout, and how we could design the Arrow format to achieve a high performance way of representing data. And it's been almost 10 years that we've been working on the project, and that's
yeah.
People are pretty happy with its existence. That's great.
It's pretty amazing. And you mentioned DuckDB. We also talked briefly about Polars in there and Pandas 2.0. And lots of these platforms are now, and data tools are using Apache Arrow. Is that right?
Yeah, that's right. And so I guess we can just start with those in order. So DuckDB, you can think of it as like SQLite for analytics. So an embeddable engine, SQL database.
Does it save as a single file the same way?
Yeah. So they have an amalgamation, like a single file, DuckDB.cpp that you can embed in your application.
Okay.
So they designed it for portability, zero dependency. You can just drop it into your application and get a full high performance database engine. It's a columnar database system. It's built off of the ideas of and the research around columnar execution engines at CWI in the Netherlands, which has been a powerhouse of database research over the last 30 years. They really wanted to solve this embeddable high performance columnar database problem. So we connected early on with DuckDB, maybe only 2 years into the project, and said, hey, we want DuckDB to work really well with Arrow. And so my company, Ursa Computing at the time, which became Voltron Data, we became sponsors of the DuckDB Foundation, and we established a working relationship with DuckDB Labs, which is the consulting company that the DuckDB developers established to support DuckDB. And we put real money behind building the Arrow integration into DuckDB, so that Arrow would become a native interchange format in lots of different applications for DuckDB.
Are there limitations to the sizes of what a DuckDB database can have?
DuckDB is really good for it. It can execute if the data can fit on your hard disk, DuckDB can probably do whatever you want with it. It's really good at memory constrained query execution, something that dataframe users, pandas or Polars users probably experience the pain of running out of memory in some intermediate operation. But like you can tell DuckDB, like, I want you to use no more than 8 GB of RAM, and it will respect your wishes. And you could be running on, a 300 GB data set that lives on your hard disk. So that's super cool. So we've also extended and made modifications to Arrow to kind of bring the memory format of Arrow like closer together with some of the extensions and ideas that have been built into DuckDB, developed kind of in the database in the database literature. So Polars, new data frame library for Python. It's written in Rust.
Yeah.
Led by Richie Fink. There's a company for Polars now, and it's fully Arrow based. It's written in Rust, and it's a really cool project, very fast. It's also like a lot more. The API surface area of Polars is a lot smaller than Pandas, which I think is a good thing in terms of like focusing on performance and scalability, and bringing a full lazy expression system to data frames.
Yeah,
and tying that into Polars' execution engine. There was a third project in there that you mentioned, and I forgot about it already.
I was just talking about Pandas going to 2.0 and adding Apache Arrow to it.
Yeah, so Pandas 2.0. So one of the focus areas in Pandas development in recent years has been the extension array subsystem, which allows you to... So initially, Pandas was based on NumPy arrays, and we built this whole complicated data management framework in the internals of data frames that would merge columns of the same type together. And one of the motivations was that we wanted to make transposing operations and pseudo like pivot tables and other linear algebra type operations in Pandas a lot faster.
Okay.
That introduced a lot of complexity, but we did it. We had reasons at the hashtag reasons at the time.
I was wondering if there are financial reasons, like that's your background of like working in that world. And I think pivot tables and things like that could have been related.
Yeah, I think there were some specific workloads that we saw over and over in the financial analytics world that definitely influenced my thinking there. And after I left AQR to go to grad school, I continued to do some consulting work for them. And so that did influence some directions in the project. But so the extension arrays allow you to have custom array types. So Pandas has introduced arrow strings and other arrow types, which has brought new features like nullability to integers and Boolean data types, which has been a pain area for Pandas users. And arrow strings provide a lot better memory use and a lot faster string processing, because string arrays and Pandas are pretty bloated. They use Python objects, and so there's a lot of overhead associated with large string arrays.
Yeah.
And so using the arrow string representation makes the string columns a lot more compact and a lot faster for processing. So that's definitely very cool, and that was a big focus for the Pandas 2.0 release. Again, it's because it's hard to change things in Pandas because we don't want to break people's legacy code, or at least not break it too often.
Yeah.
And so I think early on, I had, the hope that we might be able to forge a path for Pandas to become more Arrow native more quickly. But we found that, I didn't do the work on this, but the development team found that it was not going to be easy to migrate to using Arrow-backed Pandas data frames without introducing too many subtle edge cases and backward compatibility issues. And so it's required a more delicate and sort of deliberative approach to introduce the Arrow functionality into Pandas. I think initially it's like an opt-in, and now I think there's some limited cases where it's if PyArrow is installed, that you will get Arrow data types out.
Yeah, I think of like what NumPy are doing with their version 2, and again changing these core data types and having to kind of look forward and again potentially breaking lots of people's code and having to be aware that hey, you're not going to just be able to simply upgrade to NumPy 2. You're going to need to really look at your code and make sure that these specific types are going to be the same and work inside of it. So that is always a challenge.
Yeah, I mean, another big chronic problem in pandas is the memory doubling issue that pandas really wants to own its own memory and copy the data that you give it. And part of that is defensive copying, because for historical reasons, there were scenarios where you would create a pandas data frame and then modify that data frame, and that would modify some other arrays that you used to create the series of the data frame. And so there's a lot of places where we introduced defensive copying so that the user would not, mistakenly, bork some other some other data that they had. But as a result, like it's become pretty difficult to create a data frame that references some other memory that you have, and you can do it through pretty innocuous actions. You might have 10 gigabytes of data in memory or 5 gigabytes of data in memory, and you convert it into a pandas object, and so all of a sudden you have double the amount of data in memory because of memory copying. And so one of the motivations with the extension array work is to make it easier to do like zero copy construction of pandas data frames, so you can avoid that memory doubling issue.
This week, I want to shine a spotlight on another Real Python video course. How do you make the console output of your Python applications more interesting and attractive to end users? Making your console text-based applications more engaging is the focus of this course. It's titled Unleashing the Power of the Console with Rich, and it's based on a Real Python tutorial by Charles de Villiers. In the course, Real Python instructor Darren Jones shows you how to use the Rich package to enhance the user interface of command line tools and improve the legibility of console output. The course also shows how to create appealing dashboard displays for real-time tabular data and how to generate well-formatted reports. I think it's a worthwhile investment of your time to learn how this versatile toolkit can enable you to generate beautifully formatted and highlighted text in the console. Real Python video courses are broken into easily consumable sections, and where needed, include code examples for the techniques shown. All lessons have a transcript, including closed captions. Check out the video course. You can find a link in the show notes, or you can find it using the search tool on realpython.com. I wonder about the Apache name that's attached to Arrow, and I don't know if there's some kind of background there that relates it in some way.
Yeah, I can speak to that. So the Apache Software Foundation came about in the 1990s. So I think it was one of the, if not the first, open source foundations, 501c3 nonprofit organization that was created to provide legal protections and other infrastructure in support of open source projects in the 1990s. And so if you go back and you look at the conversations in the 90s, there was a lot of concern about attacks or like legal actions from Oracle or from IBM or like other companies who felt threatened by open source.
Sure.
And so the project that led to the creation of the foundation was the Apache web server, which the name actually was a pun. It came from the idea that it was a patchy web server. So like it had a lot of bugs, and so it required like a lot of software patches. And so people had heard the Apache name, and so that there was a pun there. And so I think they liked that, and that was how the name of the web server came about.
Okay.
Because of the name of the web server, that was the name you initially used for the foundation. Of course, it's over the last 30 years, culture has shifted. I think people have justifiable concerns about cultural appropriation and use of Native American, language and imagery and associations in these projects. Something that's brought up repeatedly and has been also a concern in the Arrow project. Many cultures, almost all cultures in the world, have invented and used arrows, but putting Apache and Arrow together creates, kind of the unfortunate imagery of like this kind of Native American connotation that, if it were up to us, like we want the benefits that the foundation offers us. And so for Arrow, we would like to not have the concern of the cultural appropriation. Like we would be in support of like a name change for the foundation and for everyone to create an inclusive community where everyone feels welcome. And it does concern me that those with Native American heritage might feel that because of this, that the community is not as inclusive as it could be. But it is something that comes up on a frequent basis.
Yeah.
And it happens to be that the big data community, Apache Hadoop, because of the legal protections infrastructure provided by the ASF, and the fact that the ASF and the Apache Software Foundation has become a trusted brand for corporate contributors to open source, because they know when they're contributing to an Apache project that they're getting not only the legal protections, the trademark and copyright handling, that the IP is all clean and is being looked after, but also that there's a governance model in place that is based on openness and transparency, all communications, all project communications, aside from certain private votes about who to give commit access to on projects. Those are private. But aside from that, all of the governance of projects is fully open. And so for a corporate contributor looking to get involved in open source, they don't want to come into some open source project that is controlled by some other company that's having private discussions. And so
Sure.
one of the mandates in an Apache project is that all communications have to be public. So that creates this kind of safe space where everyone is playing with their cards up on the table.
Okay.
And so we call it the Apache way, and that model has produced these really healthy and thriving communities. So
cool.
I don't have a huge horse in the race over the Apache name, but I want to create inclusive, healthy open source communities, and to bring everyone under a happy umbrella where we can collaborate and build great software together.
Yeah, I feel like over these years since you started all these different sort of projects, I wonder if you feel like you've become more of an organizer, a manager, and are you doing as much coding as you would like to do?
So while I was working on my recent company, Ursa Labs, then which became Ursa Computing, and then Voltron Data, as we built a 130 person company in 3 years, and so I didn't have too much time for coding during that time, and I'm getting back to my new role at Posit. I'm getting back to doing more development and working on some new open source initiatives. It's been ebb and flow as far as how much time I have for coding, and you're absolutely right that I have been kind of a community organizer, and I recognized early that because the hard problems in open source projects are not necessarily technical problems, they're actually social problems, that building relationships with people, especially long-term relationships, trying to find the right people to collaborate with, spending a lot of time to make sure that you understand each other, that you're communicating well, that you're on the same wavelength in terms of what you're trying to accomplish. But I found that influencing other people and recruiting other people to a common shared understanding of what we're trying to build, and getting on the same page, that pays great dividends. And finding and recruiting people to work with me, I view that as arguably more important than the code that I produce. Obviously, I love writing code and doing development work, and I've had periods where I've been enormously productive and churned out tons of code and tons of pull requests. But I think that the community development work, it yields a lot greater benefits over time, because if you find the right people to work with, they also recruit other people to work with them. And so if you just look at the Pandas project, I think Jeff Reback and Joris van den Bosch and Philip Cloud and Mark Garcia, they've all been just amazing in terms of community development. And I tip my hat to them. I think Pandas wouldn't be anything like it is now without their contributions to building that community. And so, I think that community organization work, I think in open source, it's everything. And I think, from the outside, often people think, oh, well, it's, these, lone wolf hackers in their attic, writing code late at night and on weekends. And, there is a lot of privilege attached with doing open source development, because many professional software engineers can't afford to do open source work on their nights and weekends because they have families, or they have other jobs, or they have other responsibilities, or they're too tired. They're too tired to do open source work. I've had many days where I'm like, I could work on GitHub issues, but I'm too tired today. And not everyone can get permission from their jobs or the space at work to be able to contribute to open source. So naturally, there's definitely, like diversity problems in open source. And yeah, I think I think for a long time, it's been a really privileged activity to be in a place where you can do open source development.
Yeah.
And so, yeah.
I think about that a lot. Like, I think about just in my time, I started the podcast, almost exactly 4 years ago, right at the start of the pandemic, and just trying to get people to come on the show to talk, the amount of bandwidth that these people had to be able to show up and do something like this, to talk about their projects, to talk about what they're doing, in watching organizers of conferences kind of go through the same thing, and what you're talking about of these different projects. And so it's just, you have to be in a really sort of special spot to be able to, like you said, contribute. And it's fantastic if you can, but like trying to get more people involved is hard, and it's going to be always one of these things that, what are the benefits that they're going to get out of it, and how much can they invest into it, and so, but I definitely appreciate everything that you've been working on and being a champion for. Do you want to talk a little bit about Ibis a little bit deeper? Because we kind of touched on it off and on, and I'm very fascinated. I mentioned lots of times on the show about being an R programmer for a little bit, and what fascinated me about it and I loved about it was definitely the sort of tidyverse stuff and dplyr. And so when I saw Ibis, I was like, oh, this looks really cool and has a lot of the same kind of stuff. And just a note, I wonder about projects like this sometimes that I feel like have been a little bit under the radar. Like, I feel like it's not something that I hear a lot about. I'm not traveling in a lot of data science circles lately. I try to get more guests involved, but I wonder about, not only getting a project started like this, but also like promoting it, which goes back to like the whole open source thing.
Yeah.
But anyway, maybe we could just talk about what it is, and then we could talk about the project itself.
Sure. Yeah. So Ibis is it's a Python library. It provides an API for data frame operations, like building lazy data frame expressions, table expressions, basically interacting with a wide spectrum of database engines and other data processing systems. And so the idea of the project was to create a portable query layer similar to what dplyr and dbplyr in R has become, enabling you to write an expression, a data frame expression in R, or a data frame expression with Ibis and Python. And then based on what execution engine you're using, it will generate the appropriate SQL query or translate it to the appropriate, pandas or polars function calls to execute that operation. So the project started in late 2014 when I was at Cloudera, and the idea was that I was looking to build Python interfaces to these big data systems, and I didn't want to build these one-off APIs for a single execution engine. So I wanted to have a common API that was data frame like or pandas like, but that had really robust support for SQL, because I had written a lot of SQL early in my career. And so I'd seen the horrors of maintaining large, 1,000-line or 100-line SQL queries.
Yeah.
And so I wanted to have the ability to write complex SQL a lot more easily, to have reusability and the features of a modern programming language like Python when I'm writing complex SQL queries. But then I also wanted to have this bridge between the data frame world and the SQL and big data analytics world. So the project started late 2014, initially had support for Impala, because I was working with the Impala SQL engine team at Cloudera. It was a bit of a sleeper project when we launched it. And Philip Cloud, who I had worked with for several years on Pandas, was like one of the key Pandas core team developers, was at Facebook in that era. And he was also suffering from massive, Hive SQL and other SQL data warehouse stuff at Facebook. And so he got interested in Ibis because it was solving similar problems that he was seeing.
Nice.
SQL maintainability, scalability problems at Facebook. And so he jumped in and added Postgres support. Somebody at some point contributed BigQuery support and ClickHouse support. Then some folks at the Google Cloud team picked up Ibis and started using it to build some internal tools and data quality tools for BigQuery. And so for a period of several years, like there were not a lot of users of Ibis, and we continued to add features and refine its internals. And it was this kind of project flying under the radar. But then in 2017, 2018, like we started using Ibis to build like a pretty serious system at 2 Sigma, where Philip and I then worked. And so that brought like a bunch of new development energy into the project. There was some development from used to be called MapD, then OmniSci, now Heavy AI. So that was a GPU database system. So they contributed some development. Google continued to contribute for a period of several years. And then fast forward to 2021, so we started Voltron Data and really making big investments in making the whole data stack more modular and composable. And it was clear that the query layer, how we interact with all these different systems and provide for modularity at the user interface level of writing queries and writing these analytical operations, that we needed a solution for that. And so we made an early commitment at Voltron Data to make a big investment in Ibis and to build a team around it. And so the project, if you look at its GitHub history, there's a big spike in 2021 where we hired Philip, and he leads a growing team there, which has made an enormous investment in modernizing Ibis and building it to now it supports 20 different execution backends, and it does, can do real-time SQL processing with Flink, and it can run against all the different data warehouses, Snowflake and BigQuery and Redshift, and it can generate Spark SQL. It's grown into a quite large project, but still, I think it's a little bit unknown in many areas of the Python community. So Philip and his team have been doing a lot of work on creating content, live streams on YouTube and blog posts. And if you go to the ibisproject.org website, there's a lot of really cool blog posts where you can see the things that they've been building more recently. And it's actually the emergence of DuckDB and DuckDB becoming this amazing, ubiquitous data processing tool has made Ibis a lot more useful, because now you've got a high performance database engine that historically would have been squirreled away inside a cloud data warehouse or a commercial database that you can pip install and use on your laptop to work with massive data sets. And Ibis gives you a really powerful Python API for generating complex DuckDB queries and really nice integration with DuckDB. So that gives you a pretty powerful toolkit right at your fingertips.
When you think about the workflow there, again, we were talking about pandas earlier with this idea of like having to write, read CSV, and having this idea of like having to move data into this other data frame kind of working relationship. This allows it to just be literally a much friendlier query type language going right against the database, as opposed to it having to be brought into data frames and having to have these other representations of the data in memory. Am I thinking of that right?
Yeah. I mean, so the way you can think about it is that we designed Ibis for a high degree of SQL compatibility. So the idea was that if you can do it in SQL, there should be a way to express the same thing in Ibis. So we wanted there to be no loss of functionality going from SQL to doing the same work in Ibis. But we provide, because we built Ibis in Python, so we could build in like a layer of type checking and validation and code reuse. And so if you think about the stuff that people are currently doing with dbt, for example, where they're writing SQL queries and then inserting Jinja templates into their SQL queries to generate these complex SQL strings. So you can actually do the same stuff in Ibis, but you are writing all Python functions and building things using modern Python programming techniques, and you get type validation and type checking all throughout the process. So if you ever make an error, you get a nice error message right away telling you exactly what you did wrong and why the expression doesn't work, rather than, I'm sure people have been frustrated working with some large SQL string where you make a mistake and there's like some error from, parse error in the SQL string or some type error. And so we wanted to create like a lot more productive and more pleasant experience for doing industrial SQL. So things that are a lot more complicated than select star.
Nice. Yeah. And it has a similar sort of I don't want to call it piping, but it has the idea of the dot notation to be able to like chain multiple things together, which reminds me of working in R and the tidyverse kind of stuff.
That's right. Yeah, yeah. So you can think of it as being like dplyr for dplyr for Python.
Yeah.
I think it has a much larger scope in terms it aspires to be a lot more SQL compatible than dplyr. So that's like a design difference.
Yeah.
But I think Ibis and Polars have converged on a pretty similar way of working, and that it's expression based. Everything is lazy. You build these expressions, and then you have the control over when it's executed. And so I honestly like SQL is not going anywhere, and I think the best thing that we can do is turn SQL into basically the assembly language of databases. So a thing that is machine generated, but humans don't have to interact with
Sure.
very very much.
One of the things that I thought was interesting in that same talk you were talking about was the ending the language wars. I feel like that's such a common thing that happens. People get involved in these sort of like flame wars over to like, what we should be using here and so forth. And I wonder what, who are the casualties of of these wars when you think about it?
Yeah, I feel like the language wars, for example, between Python and R have led to like a lot of bad feelings and like grumpiness and like hostility would be like a strong word, but generally just like unfriendliness between
Yeah.
developers in these communities. And so I think Hadley Wickham and I recognized early on that the language wars were kind of stupid, and we're all solving the same problems. And yes, we've made different technology decisions on how we solve these problems, but we stand to gain more from working together and sharing ideas, and if possible sharing code and solutions to problems than competing with each other. And so when I was just helping start Arrow, I got together with Hadley and said, what can we do with this to make the language wars get better? And so we created the Feather format. So it was a quick 2-week project to create a file format based on Arrow, and that was hugely useful to show the benefits of sharing technology between the R and Python community. And that initial collaboration in 2016 has led to almost a decade long partnership between me and our studio, now Posit. And so they helped me create Ursa Labs and put huge amounts of funding into Arrow development. They helped me incubate Ursa Computing. They're a shareholder in Voltron Data. And again, if I'd adopted the language war posture of like, I'm not going to work with anybody in the R community, then that whole collaboration would never have happened. And who knows
Yeah.
who knows where I'd be now. But I'm glad that I embraced the building bridges and not walls, and working for the benefit of building that that idea of the shared data science runtime and these reusable components that can be the rising tide that lifts all boats.
Yeah. Do you want to talk a little bit about your role at Posit and the kinds of
Yeah.
things that you're working on there?
So Posit is around a 300 person company. It was formerly known as our studio, and it was founded in 2009. So initially, they built the our studio IDE, and they've over the course of many years have company has grown. They've built a whole enterprise product suite that supports open source data science teams. Initially, are focused to start, but since have evolved to be a polyglot, language agnostic computing data science company. So they rebranded the company to reflect their growing into a polyglot computing company. Have been adding support for Python based teams to their enterprise products. Have been making some investments in open source Python development, for example, porting the Shiny framework for R to Python for building reactive and scalable web applications from Python. They've funded Arrow development, which has helped with modularity, interoperability between the R and Python ecosystem. Built the Reticulate package, which helps with building hybrid R Python applications. And so I'm doing a few things there. So I'm a software architect, so I'm providing product feedback, design, and development work across numerous products in Posit's umbrella, helping with the roadmap and feature set, and helping boost the Python support and orient the company's Python strategy to benefit data science teams. They've also afforded me a lot of bandwidth to continue to work on open source projects, which I greatly appreciate.
Yeah.
I think Posit's has one of the largest fully, open source software development teams. They have a large team there that does nothing but build open source. And so, I'm able to, one of the reasons why, I wanted to rejoin Posit was to have that platform to be able to dedicate a large fraction of my time to open source development, but also to have the exposure to the enterprise data science problem so that I could see what's going on inside large companies, large data science teams, to understand what we need to build on the open source side to really empower data scientists to be more successful in the enterprise. Because really the struggle is not R versus Python, it's open source versus closed source.
Sure.
And the vision that I share with JJ Allaire, the founder of Posit, and folks like Hadley Wickham and Joe Chang, is that we really want the world to be built on open source software and open standards. And so I believe that Posit is a place where I can do my best work, and I'm excited to spend the next potentially the rest of my career there. I mean, it's a place that I believe can be a 100-year company and aspires to be a 100-year company, and as a place where I have resources and really smart people to work with. And my work in building open source is aligned with the mission and values of the company. So very excited, for kind of this next leg of my career, and I will try to be as useful as I can and continue to build open source and help the open source data science mission succeed.
Yeah, that's awesome. Wes, I have these questions I like to ask everybody who comes on the show. And the first one is, what's something that you're excited about that's happening in the world of Python?
I'm pretty excited about the Rustification of Python.
Yeah.
I think there's two really cool companies that are building tools for making Python development better. So Astral, which builds the rough linter, and prefix.dev, which is started by Wolf Fulprecht, who created Mamba, like a faster conda.
Yeah.
And so they're all working in Rust. And so combining the ideas that have percolated the Rust community and bringing that kind of ethos and developer productivity mindset to Python, I think can only lead to good things. I recently configured Rough and LSP and all the fun things in my Emacs environment. So now I have all these fancy new development aids that I didn't have in the past, and I already feel more productive. So
that's cool.
Yeah, I think obviously that plus the use of generative AI, Copilot, and things in the development workflow, I think we're headed to really good places as far as developer productivity and a more pleasant and productive day-to-day working environment.
I had a listener send in a question to me. He was wondering, is it hype that Rust is so popular? Like what's going on with it? And so we spent like a discussion section of the last show that we did. All I can say is that the people that I speak to on the show that are developers that are out there working in the community, they're excited about it. I don't know if you would call it hype. It's definitely one of these things that it's a tool and you don't necessarily need to learn it to get everything you want out of it. There's lots of benefits of people using it. And it's just a modern language in so many ways. So I don't know how you feel about
Yeah, no, I think there is a learning curve to developing in Rust, but once you climb that initial learning curve, like what I've seen is that developers are happier and more productive. And so my former co-founder Chang Shi, he has a new company, LanceDB, building a file format for vector databases and a software as a service vector database solution. And they started out building Lance and C++, and over the holidays they said, well, what if we do this in Rust? And they found that they really loved Rust, and all of the friction that you experience with C++ development environments around packaging and tool chain and compilation and all those things, that a lot of that friction goes away. And so to have a modern systems language with a really nice development environment, tool chain, and tooling like the LSP, and the feedback that you get in the development, like the IDE support in Rust, is really good. And so ultimately, I think it's about building good system software and having productive development teams, and Rust has done a really good job of that. So I think the hype is justified. I've only written a smidgen of Rust code, and so I don't feel like I've used Rust enough to really render a judgment, but I just seeing other people around me and how happy they are to be developing in Rust. I think it's more than just hype.
Yeah. I think that's an immeasurable thing that that you can't ignore, happiness of your developers.
Yeah.
So what's something that you want to learn next? This doesn't have to be about programming.
I've always been a lifelong foreign language learner.
Okay.
Lately, I've been learning French and Italian, and so yeah, I'm interested to learn more of those. And when I have the opportunity to.
Are you using any specific tools for that?
I find tutors on Italki. Maybe some listeners have heard of Italki. It's like a language tutor marketplace, and so I've had a good experience with that studying. And since I've been studying languages since I was a teenager, and so being able to have a Skype call or a Google Meet call with a foreign language tutor, I've found a good way to learn. It does require you to do your homework and consume media and read and get exposed to the language you're trying to learn. But but that's fun. I'm trying to think what else I'm trying to learn. Yeah,
there's a commitment there that if there's a person waiting for you to show up.
Exactly.
It's like, what did you do this week? I always think about that with guitar lessons and piano lessons or things like that. It's like, they'll know right away if you've practiced.
Yeah. And I'm learning, outside of and programming things, I'm interested in learning Rust and learning TypeScript finally. So, and I'm, tinkering with DuckDB WASM.
Okay.
Which the kind of the WebAssembly version of DuckDB, and so that's hence the TypeScript. And I'm having a good time doing that.
Yeah. How can people follow the work that you do online?
You can follow me on. I have my website, wesmckinney.com, and I still post things occasionally on the website, formerly known as Twitter. Can't say I approve of Twitter's new management, but it's sad that Twitter is not what it once was. But I don't know what is going to replace it, and so I hope that something does replace it, and that there is again a public forum where we can share things and stay in touch with each other. LinkedIn is also great. I think a lot of people have stopped using Twitter and have been using LinkedIn a lot more, and so I do try to post things on LinkedIn as well. Yeah, so feel free to reach me on those platforms.
Okay.
Outside of that, I do podcasts, and I'm going to be speaking at more conferences, as part of my role at Posit. Look forward to seeing people in person.
Yeah. I learned that you are a fan of video games, and so I thought I'd just throw this one in there. What video game are you currently playing?
I would say I'm in between games. I'm about halfway through playing Alan Wake 2, which is great, but it can only be consumed in small doses because it's like hard to play right before going to bed, it's having your sleep disrupted. But
yeah, it's a little intense.
I love retro video games, and so I often like to revisit classic games, and so I really enjoyed replaying the remaster of Metroid Prime, which came out when I was 17, and so to replay it at 38 is with on my Switch and all that has been super fun. So I don't have as much time for video games as I used to, but for me it's like
understand.
It's like a way of unwinding, and it's like a stress relieving kind of thing. So
takes your brain to a different place, which is always kind of good.
Yeah.
Except for like you said, playing intense games before bedtime. Cool. Well, Wes, thanks so much for coming on the show. It's been fantastic to talk to you.
Yeah, thanks for having me.
And thanks again to Posit. Posit Connect helps make deployment the easiest step in your analytics workflows. Learn more about Posit Connect and try it for free for 3 months at pos.it/realpython. I want to thank Wes McKinney for coming on the show this week. And I want to thank you for listening to the Real Python podcast. Make sure that you click that follow button in your podcast player. And if you see a subscribe button somewhere, remember that the Real Python podcast is free. If you like the show, please leave us a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Paley, and I look forward to talking to you soon.